Welcome to this video. I am Physics, and today we are going to be going over SI and derived units as well as prefixes. First of all, what is an SI unit? SI units are base units from which all other units are derived. Some examples are on the screen here, like length and mass, which are measured in meters and kilograms respectively. But you may be wondering why some other units like newtons are not on this slide. This leads us on to derived units, which are measurements made up from the SI unit quantities, and examples are on the screen here, which include power and charge. SI and derived units will be paired up with a suitable prefix if necessary. These are all the prefixes we could have. They go all the way from tera, which is 10 to the power of 12, to femto, which is 10 to the power of minus 15. Now we'll be going over some example exam questions. So the first question is, select a row of the table that identifies an SI base unit and a derived unit. So the first column is for the SI base units, and the second column is a derived unit. So for A, we have coulomb, which is for the SI base unit. So if we go back to the slides, we can see that coulomb is a derived unit and not a base unit. So we know A is wrong. For B, we have joule, which is a derived unit and not a base unit, so you know that's wrong as well. And for C, we know that that's not an SI unit as well, due to it being a derived unit, so we know that's wrong as well. But D, we have seconds, and seconds, which we can see from the previous slides, that it is correct. It is correct, so we know straight away that it's going to be D. But for the sake of this video, we are going to be going over the derived parts as well, derived unit column as well. So in the A row, we have ampere, and ampere is a SI base unit, which we can see from the table previously, as it is the unit for current. So even though that's correct, that's incorrect as well, due to it being in the derived unit column. So volt, a volt is a derived unit. So that is correct, but the first part, which is saying that the base unit, saying that joule is a base unit, is wrong. So B is still wrong. And a kilogram, which we saw previously, is a SI base unit, so we know that C is fully wrong as well. And a watt is a derived unit, so we know that D is correct. So the next question is that which of the following is a unit for tension expressed in SI base units? Tension is a force, and force is measured in newtons. And we know that newtons is a derived unit. So if we go back to Newton's second law, we can see that F equals ma, where m equals mass and a equals acceleration. So mass is measured in kilograms and acceleration is measured in meters per second squared. So if we put them together, we get kilograms, meters, seconds to the power minus 2, and which one over here does it match? It matches D. And we know this is correct due to the fact that kilograms, meters, and seconds are SI units. So the last question is that which of the following is an SI base unit? And so we're going to go in order. So A, it says ampere, and from the previous slide, we know that automatically ampere is going to be an SI base unit. So we know it's correct. And there's no need to go over the rest because it was in the first question. The next question is that show that 65 kilometers per hour is about 18 meters per second. So we have 65 kilometers per hour. So we first deal with the numerator. So kilometers to meters. How do we go from kilometers to meters? So we know that kilometers from that table, we know that kilo is 10 to the power of 3. So to go from kilometers to normal meters, we times it by 10 to the power of 3. So we do 65 times 10 to the power of 3, which is, in other words, times it by 1,000. And we get 65,000. But the tricky part is going from hours to seconds, due to it not being in the prefix table. So First, we need to go from hours to minutes and minutes to seconds. So how do you go from hours to minutes? Hours to minutes, due to the fact that there are 60 minutes in an hour, we times it by 60. And to go from minutes to seconds, we times it by 60 as well, due to the fact that there's 60 seconds in a minute as well. So altogether, we times it by 3600. But however, we see that the hour is in the denominator, and it's also in the power of minus 1. So due to the fact that if anything is in a minus power, we need to do the opposite regardless. So instead of timesing it by 3600, we divide it by 3600. So we do 65,000 divided by 3600, and that is 18.05 reoccurring meters per second, which is therefore about 18 meters per second. And there you have it. Thank you for watching this video. I hope you have learned something, and it would be really appreciated if you could share this video and subscribe. Have a fantastic day.